Hey students, so these are the notes for section 6.4, rhombus and square. So rhombus is the singular, rhombi is the plural. A lot of times you'll hear people say rhombuses. It doesn't matter. I will probably say it both ways. So let's go to your vocab folder, still page 23, and we are going to throw some color on these two to make sure we know that we have covered them. So here's rhombus. And here's square. Definition of a rhombus is it is a parallelogram. So remember, it has the properties of a parallelogram, but it has four congruent sides. Four congruent sides. That is the actual definition of a rhombus. Actual definition of a square is a parallelogram that is a rectangle and a rhombus. So I don't use that definition a lot. What I use instead, the definition of a rectangle is that it has four right angles, and the definition of a rhombus is that it has four congruent sides. It has to have both, so it's an and. Okay, so in my picture, it is going to have four congruent sides. That's the rhombus part. And then it's going to have four right angles. That's the rectangle part. So when you put a rectangle with a rhombus, you get a square. I want to go ahead and show you this little diagram here. Okay, if this was a rectangle and this was a rhombus, when you put a rectangle and a rhombus, when they interchange with each other, when they overlap, that makes a square. So that's how we end up with a square. Okay. All right. The warm up real quick is on rectangles. So let's just, I'm going to have you answer these two questions, and then I will make two questions out of it. So go ahead and answer question one. And then answer question two. Okay. First question was talking about the diagonals. They are congruent. And so that was an easy question. Okay, this one I'm going to go over this. I'm going to show you how quick you should be able to get these angles in there. They gave me angle 2 was 40. Watch. 40, 40, 40, 40. I know this is a right angle, so this is 50, 50, 50, 50. These are isosceles triangles. So if this is 80, this is 100. And then this is vertical, same thing, isosceles. This is also isosceles triangle. This is 50, 80, and 80. Done. You should be able to get it that quick. Not kidding. Okay. All right, let's go over the properties of a rhombus. Properties of a rhombus. A rhombus is a parallelogram with four congruent sides. So you'll see pictures like this. A rhombus has all the properties of a parallelogram. Remember, there were fabulous five properties of a parallelogram. Two for the angles. We say two for the sides first. Two for the sides, two for the angles, one for the diagonal. So opposite sides are parallel, opposite sides are congruent. Opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, but they are not equal. Remember what we talked about? When your shape is straightened up and has right angles, the diagonals become equal, but when it leans, if you imagine leaning this over, this diagonal stretches, this diagonal gets shorter. So the diagonals are not congruent. A rhombus is equilateral, okay, but it is not equiangular. It is equilateral, not equiangular. The diagonals of a rhombus are perpendicular to each other. This is our first one. There are three shapes that have perpendicular diagonals, and this is the first time we're seeing it. So go ahead and draw this in. And you're going to put a right angle. What happens is all four of these triangles are the same triangles. You could fold this in half this way and then fold it in half that way again, and you would end up with one little triangle. These are all the same triangles. You can use Pythagorean theorem. If I gave you a side, if I told you this was 10 and I gave you another side, you could find the missing side using the Pythagorean theorem. And there is an isosceles triangle here. Notice isosceles triangle, the big triangle. isosceles triangle, and so on. And the diagonals of a rhombus bisect the angles. So I want you to put these dots in. I think the dots helped when I put them in for the rectangle, so I want you to watch. In a rhombus, this is the big thing. This is the big thing for you to know. All four of those angles are equal because a rhombus can be folded in half. A parallelogram cannot be folded on the diagonal, but a rhombus can. So it can be folded this way. These angles will map right on top of those, and then it can be folded over again. And that shows you that these angles are all the same. Likewise, all of these angles are the same. And then all four of these angles are 90. So now you can get a visual and you can see this is a right triangle. If this is 40, this is 50, this is 50, this is 40, this is 40, this is 50, this is 50, this is 40. There's only 3 angle measures in a rhombus. Learn it, okay? But this part right here, there's going to be 3 figures that have perpendicular diagonals. That'll help you later on. Okay, I told you the definition of a square, and sometimes a square is defined as a rectangle and a rhombus. A square has all the properties of a rectangle. There were 2. Okay, all the corner angles are 90. Okay, and the diagonals are congruent. So this time the diagonals are congruent. Because it's a parallelogram, the diagonals were bisected, and now they're congruent, so it looks like that. A square has, so the diagonals are congruent, right angles, those are the 2 properties of a rectangle. The 5 properties of a parallelogram: opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and then the diagonals are bisected. Those are the fabulous 5. And then the square has all the properties of a rhombus. All 4 sides are the same. Okay, and the diagonals are perpendicular. So 2 properties there. Okay. I feel like I missed one. Oh, the diagonals of a rhombus bisect the angles. So that means if you have a 90-degree angle being bisected, there's only 2 angle measures in here. In a square, you're either going to be 45 or you're going to be 90. 90 in the middle, 90 in the corners, but all the little angles are going to be 45. Isosceles right triangles in here, all the way around. Okay? So get that picture in your head. It has everything. All right. Okay, if AB is 2x, let's see what AB is talking about. This segment right here, 2x plus 4, and CD is 3x minus 5. Then find BC and find BD. Okay, very easy. So we are looking at a square. Opposite sides are congruent. Would you go ahead and work that out and tell me what BC is going to be equal to? Remember, it's a square, so whatever you get here and here is going to be the same here and here. Go ahead and figure that out. All right, you should have got 22. Now let's talk about BD. In a square, we have right angles. We are allowed to use the Pythagorean theorem as well. So if we're going to find BD, which is the hypotenuse right here, then I'm going to use this triangle here. I really recommend when you're using the Pythagorean theorem, go ahead and find your right triangle and just highlight it. Okay, so this is going to be 22 squared plus 22 squared equals C squared. A squared plus B squared equals C squared. Grab the calculator. Can I see how I put that in my calculator? I don't need to see the numbers. That you can do that in your calculator. So I've got 968 equals C squared. So C is 31.1. Okay. Now, you guys have to be careful. If I ever ask you to leave that as an exact answer, then you would need to break it down and give me a radical answer. So trying to think of perfect squares. 25 doesn't go into it. 4 goes into it. Let's see. 968. That's why 4 goes into it. So let's break this down. So if I said 4, 242, so that would be 2 radical 242. And let's see if there's a perfect square in 242. 4 doesn't go into it. 9. 9 doesn't go into it. 16 doesn't go into it. 25 doesn't go into it. 36 won't go into it because it's not divisible by 4. I think 242 won't have another perfect square in it. Because it's, oh, duh, 121. So 2 times 121, that is 11. So 11 times 2 is 22 radical 2, which means okay, 484 was an unrecognizable perfect square, but that's how we could have got that. So if I ask you for an exact answer, you have to do what we did on the first day with the algebra review, where you break down the radicals into a simplified radical. Okay, but I'll let you know if you have to do that. Okay, next question. If the measure of angle AEB is this angle here, don't forget in a square that angle is 90. So we would say 3x equals 90, x equals 30. So now it doesn't mean the angle's 30. That means the angle's still 90. It just means x equals 30. Okay, angle BAC. So angle BAC is right here. So you need to remember that this is a rhombus. Also, a square is a rhombus, a square is a rectangle. So these angles have been cut in half. So that means they are 45. So you will say 9x equals 45 and x equals 5. So little things like that, you have to know about a square. There's not much you can do with a square. You can do Pythagorean theorem, and you can do 90, and you can do 45, and there's not much more. So you just have to think about what they're giving you, and don't mess it up. Okay. Oh, by the way, there are 2 ways you could do Pythagorean theorem. I did the Pythagorean theorem with this big triangle. If they give you this piece here, like let's say this is 5 and 5, because they would be the same, you could do the Pythagorean theorem in the little triangle to get the edge here. So you could do Pythagorean theorem with the big triangle or little triangle, depending on the pieces that they give you. Okay. The perimeter of the square is 32. So remember, a square, all the edges are the same. So if it's 32, you have to say, well, 32 divided by 4 is 8. Find the length of the diagonal. So this is going to be Pythagorean theorem. 8 squared plus 8 squared equals c squared. 128. This one's very doable. Let's give an exact answer. So square root of 128. So I need a perfect square that goes into 128. And it looks like 64. Yeah. So 128 is 64 times 2. Just thinking of my big perfect squares that go into it, square root of 64 is 8. So my diagonal would be 8 square root of 2. If I asked you for the decimal answer, you would just take the square root of 128, which is 11.3. Okay, looking at the rhombus. So properties of a rhombus, the diagonals are not equal. Look at it. This diagonal is longer. Anytime your shape is leaning, your diagonals are not going to be equal. So this is talking about DM and ML. In a rhombus, all 4 sides are equal. And so then it's asking you for the measure of KL. This is really easy. So DM is 6y plus 4. That equals ML. So that's going to be y equals 4. And then find KL. KL is going to be when I substitute back in. Now, don't make the mistake of putting 4. We're going to substitute back in. 6 times 4 is 24, 28. So KL is 28. All of these edges would be 28. Okay, if the measure of angle D is 7x minus 28 and the measure of angle K is 10x minus 13. All right, let's talk about this. Remember, a rhombus is a parallelogram. So in this picture, you are going to have consecutive interior angles. Okay, so you've got the big angle and the big angle here are going to add to 180. You have to remember this is a parallelogram. The other thing you're also going to have in these pictures is you're going to have alternate interior angles. Because you've got parallel lines, you have alternate interior angles. Don't forget all of that. So anyways, this is talking about the big angle D. I don't like it when they do that because there's not an angle D in this picture. But this angle, and I like to do this when I'm talking about the big angle, and then the angle K over here. So we're going to say 7x minus 28 plus 10x minus 13 is equal to 180. And it says find the angles in the rhombus. Okay. So here we go. Let's find x first. Okay, we get x equals 13. So now to find angle D, 7 times 13 minus 28. Angle D is 63 degrees. Oh, lovely that they gave us not an even number. So that means angle K, 130 minus 13 is 117. I just plugged in right here. All right, these two angles should add to 180. So that means to find all the angles in this picture, these 4 angles here are 63 divided by 2, which is 31.5. All of these angles here are 117 divided by 2, which is 58.5. And then these angles in here are 90. Don't forget about those. Okay, this big angle down here is 117. Opposite angles are equal. This big angle over here is 63. Okay, so remember, you got to remember that you do have a parallelogram, and we put a lot of work into that. All right, would you take this picture, fill in these answers? I'm going to ask you a question. Okay, so the question that I asked you was, what was the measure of angle 4? And it was 32 degrees. I also want you to look at what I did in the picture. I've got all the little angles in here, but I want you to not remember or not forget that the big angles are these two angles added together. So this angle is 64, this angle is 116. These are supplementary, these are supplementary, these are supplementary, these are supplementary, these are equal, these are equal. Don't forget that. Okay. Okay, the last question on this page. Go ahead and draw a rhombus. You're drawing a parallelogram, but it's a little shorter. Okay, so draw a rhombus. All 4 sides are equal. Put the diagonals in. I'm going to show you something that you need to do. Okay, when you see this, the diagonals of a rhombus are 10 and 24. Don't put a 10 in this picture. You need to know the diagonals are bisected. You need to do like I told you before. Put those numbers on the diagonal so you know that this is 10, but it's really 5 and 5. This is 24, so this is really 12 and 12. So you can see what you're doing. This is find the length of the side of a rhombus, so we're going to find the length using the Pythagorean theorem because this is your right angle. So 5 squared plus 12 squared equals c squared. 25 plus 144. 44, 5, 6, 7, 169, and the square root of 169 is 13. So this side would be 13. Okay. All right, let's look at some proofs. Okay, let's look at this proof. This is not a hard proof. Okay, so what we're looking at is I have a rhombus right here. This is my rhombus. Okay, ignore my markings right now. I'll explain them as I go. And this right here is just showing that they took part of the rhombus and they extended it. So that's why they have that in here. Line FEC was extended. That's, something you can put in, something you can leave out. I actually left it out because I didn't have room. So that's just telling you that off of the rhombus we have a line extended. Okay. We're trying to show, by the way, that these two pieces are equal, so go ahead and highlight those. And we also have FAB. It's not angle 1. I changed what I was doing there. FAB is this big angle here, and DCB is this big angle here. Okay, so we have those equal. All right, so what do you know about a rhombus? What can I use from a rhombus to get this triangle congruent to this triangle? Okay, well, first of all, I figured out that since I have the big angles here, I'm going to have to do angle addition postulate, and I'm going to have to do subtraction to get these angles equal to each other. So I knew that angle 1 is congruent to angle 2. Write that down. Now, this is what you need to pay attention to. Even though I'm in a rhombus, you need to write the reason for the first time that you saw that property show up. This is a property of a parallelogram, and a rhombus is a parallelogram. So instead of saying opposite angles in a rhombus are congruent, we're going to use the parallelogram one that we've been using. So if parallelogram, then opposite angles congruent. Okay, so now we've got this angle equal to this angle. Okay, so now do your angle addition postulate, and I'm using my numbers. Angle 1 plus angle 3 equals angle FAB. Angle 2 plus angle 4 equals angle BCD, or DCB. We'll try it the way they have it, DCB. And that is angle addition postulate. Okay, these two pieces right here are right here. So if they're equal, if these two are equal, these two are equal. Guys, how many times have you seen that? Okay, so we're going to say angle 1 plus angle 3 equals angle 2 plus angle 4. And that is substitution. Okay, so now we have this. Do y'all see how this all flows together? These are equal, so I can subtract them. So we're going to say angle 3 equals angle 4, or is congruent. It doesn't matter. Angle 3 is congruent to angle 4, subtraction. Remember, if we were using definition of congruence, it would add more steps to our proof. But I'm not worried if you put congruent or equals. Okay, so now we have, I'm going to go and color it in, this angle equal to this angle. Okay. The next thing we have is these pieces here. Remember, we're in a rhombus. All 4 pieces are equal. So I can say AE, segment AE is congruent to segment EC. Now, this is something we're just going to make up, okay? We have a rhombus, so we're going to say if we have a rhombus, if rhombus, and you can abbreviate, then all sides congruent. Okay, if we have a rhombus, all sides are congruent. So now we have this. What about angle 5 and 6? BAT. So now I have these angles congruent. Okay. That was my 5. That was my 6. Okay. Do you see it? Angle, side, angle. So now we're going to say our triangles are congruent. Let's say triangle AFE is congruent to triangle, if I go AFE, I'm going to go CDE. angle, side angle, and then I'm able to finish my proof by saying FE is congruent to DE by CP/CTC. Tell me that was not a difficult proof. That was not a difficult proof. Okay, but I'm not going to make you do this next one. We may do it in class. Okay, so let's just go over here and look at the challenge. It says in the diagram, quadrilateral MATH is a square, so the big thing is a square. G is the midpoint, so that means these pieces are equal. E is the midpoint of TH, so these pieces are equal. And AT equals 6. Find the area of the quadrilateral MGTE. MGTE is going to be, it looks like a parallelogram, but let's see if we can figure it out. So this is 3, this is 3, this is 6. E is the midpoint of TH, so this has to be 3 and 3, so these are all the same. Put that marking on there. And so to get the area of a parallelogram, actually what we're going to do, because we don't know for sure that's a parallelogram, is we're going to find the area of the square is side squared, so 6 squared, which is 36. So that's the whole thing. Let's find the area of these triangles. Okay, area of the triangle is 1/2 base times height. And if you're looking at these triangles this way, this can be your base, this can be your height. So 1/2 times 6 times 3. 6 times 3 is 18. Half of 18 is 9. So each of these are 9. So if I take 36, which is the area of the whole thing, subtract the area of the two triangles, we get 36 minus 9 minus 9, which is 18. So the area is 18, which is 3. Love it. So once again, we don't know this is a parallelogram, so we can't assume. We also, the area of a parallelogram is base times height. We don't have the height. Well, we do have the height of it. So the height is, you can see it right here. The neat thing about a parallelogram is the height can be on the inside or it can be the outside. If you think of it like this, okay, this is the base and this is the height. But again, you know, I could prove that these lines are parallel, but I would have rather done it this way than to assume that it's parallelogram. Okay, so these are the summaries. I'm going to let you read those on your own. These pictures are fabulous. I was drawing them on the front. This is where you need to go if you need to see what's going on with the square and what's going on with a rhombus. Okay? All right, let's do this exit ticket together. So we're going to check which one has each of these properties. All the properties of a parallelogram. All of those are parallelograms. Guess what? We move out of parallelograms now and move into the non-parallelogram shapes. Equiangular, 4 corner angles. That would be the rectangle and the square. Equilateral, 4 congruent sides. That would be the rhombus and the square. Nothing there. Diagonals bisect the corner angles. So that happens in the rhombus and it happens in the square. The rectangle, remember the dots? When you draw a rectangle, you have, I don't have a rectangle on this page, but when you have a rectangle, these angles are not equal to each other. Okay. Diagonals are congruent. Remember, if it's leaning over, the diagonals are not congruent, so that has to be here and here. And then the diagonals are perpendicular, rhombus, and square. What do you notice? A square, I like to call the square the tag along. All right. If it's a rectangle, it's automatically a square. If it's a rhombus, it's automatically a square. If it's so you know, if it's a square, it's automatically all these others, but the square has all the properties of these other shapes. So he's like the little tag along. When you have one of these like charts that you're going to fill out, square will always be whatever these are. Okay. All right, you're done with the notes. Thanks, students.